Hello there. We're still discussing fluids. In a previous lesson, we learned about the peculiar nature of liquids called surface tension. Now, in this lesson, we will also learn about another unique property of liquids that we will refer to as capillarity. Now, what is capillarity? Capillarity is the tendency of a liquid to rise or fall in a narrow tube. So suppose we place three narrow tubes of increasing diameter into a bowl of water. You would observe that the water rises in all the tubes. The narrower the diameter, the higher the water rises in this tube. And the top of the water column curves slightly downward and makes what we call an angle of contact with the edges of the tube. This curve is called a meniscus. Observe from the image that the meniscus makes an angle with the wall of the tube that we labeled theta. This is known as the contact angle. The contact angle is an angle measured between the tangent to the meniscus and the wall of the tube at the point where this liquid meets the wall of the tube. Now suppose we change this liquid to mercury. Something completely different happens. This time, the mercury drops in the tube. The narrower the tube, the lower the mercury drops in that tube. The meniscus of mercury is also different. It points upward, and the contact angle changes too. Now, why is this? Two kinds of force will be used to explain this occurrence. These are the intermolecular forces known as cohesion and adhesion. Now, cohesion is the force of attraction between molecules of the same kind, while adhesion is the force of attraction between molecules of different kinds. A tip to differentiate between these two forces is to remember that glues are called adhesives because they help us join materials of different types. Cohesion and adhesion can also be used to explain the formation of droplets on a glass. So in water, where the forces of adhesion are greater than those of cohesion, the water wets the glass and spreads easily along the glass. Now, on the other hand, mercury does not wet glass. The droplets it tends to form are round and will roll off the glass if the glass is tilted, without leaving any mercury residue. Now, this is because the forces of cohesion in the mercury are much greater than the force of adhesion to the glass. So now we can say capillarity is the result of surface tension, cohesion, and adhesion acting together in different ways. So when a narrow tube enters a bowl of water, the forces of adhesion between the water and the tube will pull up the water at the edges of the tube, causing the water to start rising through the tube. The water particles at the edge of the tube now pull the rest of the water in the middle along via cohesion while it rises in that tube. The surface of the rising water is held up by surface tension as the water continues to rise until the sum of all these forces acting upward is balanced by the weight of the water acting downward. And at this point, the liquid stops rising in the tube. Now in mercury, the case is different. The liquid does not rise. Instead, the force of cohesion between the molecules of mercury is stronger than the force of adhesion between mercury and the tube. This is why the mercury reduces its surface area of contact with the tube by going lower in the tube. Now, capillarity can be seen all around us if you look closely. Capillarity can be observed in the way a dry towel does not absorb a drop of water immediately, due to the low adhesion between the water and the towel. But a damp cloth absorbs more water because there is greater force of cohesion between the water in the towel and the water on the outside of this towel. Water also rises through stems of plants using the effect of capillarity. And in the same way, kerosene rises through the wick of a kerosene lamp, still using capillarity. Did you also know that this is what helps you to pull a drink to your mouth when you're using a straw? Now see if you can come up with any more examples of capillarity in action around you. But before we go, let us do a quick recap. In this lesson, we learned about capillarity, which is the tendency of a liquid to rise and fall in a narrow tube. We also learned about the forces of attraction between molecules of the same kind, known as cohesion, and forces of attraction between molecules of different kinds, known as adhesion. And then we also learned a few applications of these forces in real life. Now, in the next lesson, we will be discussing more properties of fluids. So I'll see you there.